now deal with equations in quadratic form. I'm going to make the substitution u equals y squared minus 3. U is the variable we usually use, and that simplifies this equation down to u squared minus 9u minus 52 equals 0. We know that 52 is equal to 13 times 4, so we can factor this into u minus 13 times u plus 4 is equal to 0, and then solve this to get u equals 13 or u equals negative 4. However, the original equation had the variable y in it, and we've just solved for u. So we're going to back substitute, change u back into the y squared minus 3 that it actually is, and that will give us one equation of y squared minus 3 equals 13, or y squared minus 3 equals negative 4. Let's focus on this first equation. We have y squared equals 16 after we add 3 to both sides, and that means y will equal plus or minus 4. And for the second equation, when we add 3 to both sides, we get y squared equals negative 1, and that means y will equal plus or minus I. So our solution set to this problem contains 4 numbers, plus and minus 4, as well as plus and minus I. For this next problem, I'm going to make the substitution u equals d to the 1/3, and rewrite this equation now as 3u squared minus u minus 4 equals 0. This is then factorable into 3u minus 4 times u plus 1, and we can find that u is equal to 4/3, or u is equal to negative 1. But again, we need to back substitute and change u into d to the 1/3. So we're going to have d to the 1/3 is equal to 4/3, or it's equal to negative 1. We can undo that cube root by cubing each side, and this will give us d equals 64 over 27, or d is equal to negative 1. And those are the two values that we write in our solution set. Finally, we have a literal equation. We're being asked to solve for p. And we are going to clear the denominators by multiplying through by the least common denominator, f, p, q. In each term, we're going to have some cancellation. On the left, when we cancel the f, we are left with pq equals, first fraction on the right, the p will cancel, leaving fq, plus q's will cancel, leaving fp. Now we look at where our p's are. There's one on the left and one on the right, and we want to get them all together on one side. So I'm going to subtract fp on each side. This gives us pq minus fp equals fq. We can now get the p together on the left by factoring it out of the left-hand side, and then we can isolate it by dividing each side by q minus f. So p will equal fq over q minus f.